Hi everyone, welcome to this episode of Keipert Labs. In this video today we're going to be talking about molecular compounds. Okay, so far in our studies that we've drawn the difference between ionic and molecular substances. Okay, we've identified these being two kind of categories. Ionic compounds being made up of ions, we're talking positive and negative, charged. Molecular being made up of molecules, as the name would suggest, okay, which are neutral overall. Okay, that we're talking about with ionic, we're talking about connections throughout the whole structure, whereas molecular only have some connections. So that is connections within the molecule, but not between. Okay, and we've seen that ionic substances conduct electricity when molten, that melted down, or kind of in this fluid sort of state, molten or in solution, and then molecular do not conduct. Okay, so we're seeing that these are two kind of distinctly different types of compounds. Okay, we've looked through the rules for naming ionic compounds, and now we're going to look through the rules for naming molecular compounds. Okay, so remember when we're talking about molecular compounds, we're talking about non-metals only. Okay, non-metals only. So, e.g., carbon, hydrogen, oxygen, sulfur, you get the idea. Okay, and so we're talking about binary compounds at the moment. So that is two elements. Okay, so we're not going the whole hog and looking at things that have more than that. We're just trying to keep things simple. Okay, but we looked at the naming rules for ions and how ions would come together. But molecular compounds need some similar rules, but things that are slightly different as well. I'm going to illustrate a key kind of idea here. Okay, so let's take the elements carbon and oxygen. Okay, so let's say that I'm going to do carbon as red and oxygen as blue. I'm using my nice little magnetic dots here. Okay, so what I can recognize is that there are two different ways that, way back when in Unit 3 we looked at this idea, two different ways that carbon and oxygen can come together to form a compound. The first one looks like this. The second one looks like this. I'll bring that up a little bit. Okay, so what we have here is that we've got one carbon for every one oxygen here. So if I'm writing its formula, I've got one carbon and one oxygen. Over here, for every one carbon, I've got two oxygens, CO2. So I use the subscript of 2 to represent that I've got two oxygens for every one carbon. Okay, so the 2 comes after the oxygen here. But now I'm in a situation where I recognize there's two different things here. But so if I just said this is carbon oxide, then I'm going to very quickly run into a problem, because now I've got two compounds that I could realistically name that way, but they're not the same thing, and I need them to be clearly seen to be different. So what I need to do is I need to somehow express that I have carbon and oxygen, and I want to express something about the ratio of carbons to oxygens in my compound. So what I'm going to do in this situation is I'm going to say I've got carbon, and then I want to express, and so same thing with both. I'm going to start off with carbon, and then something that expresses how many oxygens I have. That I've got 1 here and 2 here. So what we do is I'm going to write mono and di. Okay, so when we're thinking about this, we're thinking about the Greek kind of alphabet. So we're going to start to use mono, di, tri, tetra, which is 4, penta, hexa, and 6. Realistically, we're not going to go any further than that, but that's the idea. Okay, so I've got mono, and then I want to talk about oxygen. Now I could say carbon, mono, oxygen, but I want to show that they're connected together and they're joined to make a compound. So what I'm going to do is I'm going to say monooxide. rather than writing monooxide and putting two O's together and making it look like monoxide, which sounds like someone with an accent doing it, I'm going to just call it carbon monoxide. And then I'm going to call this one carbon dioxide. Okay? So the mono and the di in this situation help to show us the differences between these two versions of this compound. Okay? So we use prefixes to show ratios. Okay, how many of that element are present in our compound? Okay, let's look at another couple of quick examples. Okay, so let's look at and say I've got P2O5. Okay, and we're going to work out how would we name this substance. Okay, so let's say in this situation that my phosphoruses are red, and then what did I have? Okay, let's say then it kind of looks like a weird sort of smiley face. Okay, so I've got phosphorus, and I've got oxygen. In a compound, I'm going to make it oxide, ending in IDE. And now I'm going to use my prefixes to show the relative amounts of these two things. So 2 is di, and then 5 is penta. Now, because pentaoxide is a little bit clumsy, I'm just going to take the A out and make it pentoxide. Diphosphorus pentoxide. Okay, now let's have a look at an example where we start with the name and look at its formula. Okay, so looking at what I've got here, I've got ICl3. Okay, so I've done the I with the top and tail to try and make it a bit clearer to distinguish from this, which is a lowercase l. Okay, so I've got two elements, iodine and chlorine, written in that order. Okay, so I'm going to start iodine, and then I've got chloride to show that it's in a compound, and then because I've got 3 chlorines, I'm going to use tri, so I'm going to say it's iodine trichloride. Now obviously that's a bit of a large space, but I was kind of assembling it to show you the idea. Okay, now if I just quickly, N2O4, so I've got nitrogen, and I've got oxide. Okay, so I've got 2 nitrogens, so I've got dinitrogen, and 4 oxygens makes dinitrogen tetroxide. Okay, so where we would have 2 vowels next to each other, we just kind of clip one off, just because it is neater and easier to pronounce. Okay, so let's have a look at some quick kind of summary rules. Okay, so first element, the first element name stays the same. The second element we clip off the end and change it to IDE. Okay, we use mono, di, or etc. to show ratios. The only exception is that no mono on the first element. Okay, so we don't make monocarbon dioxide, we just make carbon dioxide. Okay, if it's more than one, we would put di, tri, tetra, etc. Okay, so the first element stays the same, second element ends in IDE. Now here's a very generally, okay, not a very, it's not an ironclad kind of rule. So the element either that's further left or down is written and / named first. Okay, so iodine trichloride and not trichlorine iodide. Okay, carbon dioxide and not dioxygen carbide. Okay, so that's generally, now there is a little bit more of a specific pattern in the more specific rules, but you don't need to memorize that. Okay, but the idea being that this is the sort of general principle that we use. Okay, you got some practice exercises, get to work, and good luck. All right, thanks very much for watching. Bye for now.